welcome to Basic Math. Today we're going to be looking at percent increases, decreases, and discounts. So we're only going to do a couple of examples here because these are very similar to the percent problems that we looked at in some of the other videos that I've done. So, but we'll look at one pretty standard one, and then we'll look at one that's a little bit trickier. Basically, what's going to make these different is now we're going to end up either adding or subtracting at the end of the problem. Or in the case of the trickier one, there'll be a little bit of addition or subtraction right at the beginning that's going to make things very interesting. But that'll be our next example. So let's get to this first one. It says a person earns $40,000 per year and receives a raise of 7%. What is their new salary? Okay, so here's the thing. The 7% here represents the amount of their raise. So we can find that, and that's going to be really pretty. If you can do the other percent problems, you can do this. It's just the same thing. But that's not going to be where we stop because we want their final salary. So at the end of this problem, we're going to end up adding that new raise onto the original salary. So let's take a look. So I set it up here. We can see it. We have the 7%. So I use 0.07 because remember, since I'm using the equation form, I need my percent to be written as a decimal. The $40,000 is the original salary, so that's going to be the whole or the base for the problem. And over here you can see I have X, that's what I'm trying to find, that's going to be the raise here. So I do my multiplication, which gives me $2,800. Again, this is not where we want to stop. The problem specifically asks for the new salary. $2,800 is not the new salary. If this was this person's new salary, they'd be really grumpy because their pay just got cut a lot. So all that's left, and so this really just requires us to pay attention and to not forget to finish the problem. All that's left is to take the raise and add it onto the original salary, giving this person a new salary of $42,800. So that's pretty straightforward. And we can see this kind of problem either with an increase, like with this salary problem, or a decrease. You could have something that was on sale and you want to find the new sale price, and so the price goes down. Okay, and so there would be some subtraction there to get to that new price. But those are pretty straightforward. Our next example is going to be a little bit weird, and so hang on, let me get the board changed and we'll talk about it. Okay, so for our next example, this is an example of one that's a little bit trickier. So the problem says a pair of shoes is marked 20% off. If the sale price is $20, what was the original price? So importantly, the discount has already happened here, right? The price has already been dropped to get us to this $20. So we're going to try and work this one kind of sort of backwards to find the original price. So with percent increase and decrease problems, we said you find that percent, or you work the problem, and then you have to do some addition or subtraction at the end. But in this case, since we're trying to go backwards to find the original, the addition or subtraction has to happen at the beginning, and here's where it's going to happen. We need to subtract with that percentage, because this pair of shoes is 20% off, but $20 is the amount that you are still paying for those shoes. Let me say that again. They're marked 20% off, but $20 is what you are still paying for those shoes. So anytime you get this setup where you're trying to back it up and find the original, what you're going to do is you're going to either add or subtract. Depends on what kind of thing you're looking at. This one's a subtraction problem because in this case you're still going to be paying 80% of the cost. Right, you're taking 20% away, so 100 minus 20 leaves us still paying 80% of the price. So I'm going to use 80% then as my percent. So my percent is 80. I'm trying to find the original price, so there's my X, and it is equal to the sale price of $20. When I divide both sides by 0.8, I get an answer of $25, which makes sense, right? The original price here is higher than the sale price, and so that's good. If you use 20%, oh man, well, you still might get something bigger, but it would be wrong. So please be really careful. Anytime you have this set up where you have that percent of a discount, or it could be an increase, probably not with like a sale, but anyway. And you have the new price or the new whatever that number is. If you're trying to work it backwards to find the original, please make sure that you do this a little bit over here first. Change that percentage, okay? If your percentage is going down, right, because it's a sale, use subtraction. If your percentage is going up, I don't know, enrollment increase at a college. That would be an increase in, then add it. But make sure you do that first because that's going to make this all work. So have a great day.